Hey. Yep. Yes, we can get started. Welcome back, everyone. We've been having great sessions all through today. Now, Carlo, try to pronounce it correctly, will be introducing us to one more thing we have to worry about in the endless list of things that is happening to supply chain security. This time, thanks to AI. So he'll be talking about Slobsquatting.
Yay!
Carlo.
So I just said before that I had a really positive panel about software engineering, where we are and all of that stuff, and now it's time to destroy everybody's hopes and dreams and everything around software. So I'm Kalle, I work as a field CTO nowadays, so since I changed the role. But I'm going to be talking about supply chains most of the time, and about software supply chains and how we're basically being destroyed by AI and its different use cases. So most of you probably see these kind of posts every now and then and you're like laughing at these. So AI white coders being in the internet and being like, oh my god, I'm being hacked and I'm being like, I'm not technical, I need help. The sad thing is the same things that these guys are doing is happening to our enterprise software. So they're most of the time just prompting against AI and it's using ready-made libraries, it's using invented libraries in the worst case, a bit less now, and it's getting constantly barraged with different kind of CVs, vulnerabilities, and capabilities. It's what creates this problem that we are seeing like a massive amount of organizations saying that they want to be faster, they want to make more AI stuff. And then in reality, 91% of the organizations have no idea how to implement AI. 85% of them are like, yeah, it actually didn't integrate at all into our existing workflows. You've probably seen this, like you probably have about 6 AI tools now and you're like, none of them actually work on the workflow that I want them to work. And then you try to solve it with cloud code. And it becomes this massive headache where the management is trying to figure out where's the AI. You're trying to figure out how does it even work, because nobody's training you on it. And on the other hand, the attackers are actually inventing how do you use it. And it becomes a massive headache in real life situations. The fact is, the AI models, the whole LLMs, everything that we're talking about is just stored math. Like it's vectors in matrix. That's all it does when you're using an LLM. Everything magical happens outside of the GPU calculation, actually. So when you see AI doing thinking, for example, that's a for loop or while loop. You can think of whichever way you want. It's going back and forth against the model and creating a plan and structuring things. And that means that most of the time, this is just information that you're giving to a tool. Or if it's the information that you're giving to a tool and stored state of a historical situation, especially with AI, that means one thing every time. It means that while we're automating, the hacker man is there. He's coming in and he's trying to get into your systems, like they've always tried. Like most of the people in security are in security because we had a nice hobby as younglings where we really enjoyed trying different things and accidentally got into one system and we got that rush and we were like, oh my god, I'm gonna get into security. Then we got into security and we realized that's not actually fun, but one can dream. The big thing is, these guys, most of the time, they're not hackermans, they're still script kiddies. They're most of the time just taking a ready-made tool from internet, copy-pasting it and running it on terminal. Now they don't even need to go to internet and copy-paste the thing, they can just install cloud code and tell it hack this system and it will boot tools from the internet and try attacking against you. They don't even need to do the 5 minutes of finding a hacking tool. Why it's a problem? Well, it's because when we give bad data into a system that stores data, we get bad data out. So this is Sonatype's previous year's thing, because I didn't bother to get this year's data because it's the same, it keeps going up and it keeps going up and up. We're getting about 1 million malicious packages per year at the moment to these different systems. So you can imagine the amount of attack vectors that are in NPM, Python, or not Maven Central. This is from Maven Central. So this is from a dead language, because like who writes Java today? We've never seen Java anywhere. It's still one of the most popular languages, but yeah. So the big thing is the amount of vulnerabilities that we're pushing into the system is ridiculous. At the same time, the whole software engineering practice that we're doing is still kind of work in progress. The worrisome thing here is this 13% of the downloads of Log4j are still vulnerable. We're still like not updating those packages. We're still like running old packages on different systems. We're still getting them from internet. We're still having this situation where 0.5% of the code that is open source doesn't have an update. But if you go and ask the engineer, they're going to tell you that there is no update for it. But the reality is most of the packages actually have an update for the CVEs or things that are found. We're seeing, for example, in GitHub, if you look at the open source community being like, oh my god, we're getting all these attacks, or like, not attacks even, pull requests about vulnerabilities. And you might be scared, oh my god, so many vulnerabilities, there's 600 security incidents open here. Yeah, it's all the same, it's that one vulnerability that your AI finds, and it's not actually even vulnerability. It's the same when you ran Jenkins and you got a security analyst coming in, and they would run against the Jenkins and they would be like, I can do remote code execution on Jenkins. And you're like, yeah, there's a shell command in Jenkins. You can do remote code execution on Jenkins. That's kind of the point of this system. I don't know if anybody of you got that, but like I had a really fun time with one security auditor talking about shell commands in Jenkins. Yeah, 80% of the applications depend on things like human upgrading packages. It depends on someone actually going in and changing a version of the number. Like, most of the people have not actually heard of what is a dependabot on the engineering side. Most of these packages they don't even understand why should they update packages. On the other side, this year, if you noticed, updating packages is getting also bad. Because if you update your packages immediately when the new version comes out, you might actually get some kind of a worm on your system. We're going to be talking about worms in a bit. But the big thing is, you end up in a situation where most of the time, people are not actually updating. So you think you're safe from the worms. But you're not, because the problem is, we're very dependent on these open source systems. We're very, very heavily gotten used to installing different packages. You can take White, which is very small JavaScript library. You get 200 packages on your laptop. One of those packages needs to have a remote code execution, a secret stealing, leakage, or cyberload in it. If you don't know what cyberload is, you will know by the end of this session. But 200 packages, and that's third biggest JavaScript library. The second biggest is Next.js. That has, depending on which you choose, 280 to 600 external packages in it. So when you run it and install it, a new software, you get 280 to 600 dependencies on your code base. Nobody's going to review those manually, by the way. Nobody knows what goes into it. And you can develop those with basically any language, and it might not actually even support anything else than JavaScript. It doesn't. And now with Next.js, they just released a Rust version of it. So now your Rust programmers here who thought that you don't have these dependencies, you have the same dependencies, by the way, now. Thank you. Fantastic. And then, the worst of all, the original deprecated React install, which most of the React applications have been done, had over 1,000 packages in it. So when you did the React quick start, you installed 1,000 JavaScript libraries on your laptop. How many of you actually did that? Because I, for example, did that because I was trying to study how to write React. I still don't know how to make front end, but that was great. There's also research that depending on where you are, you can end up in 20 to 40% of hallucinated packages. Because the LLMs are not great at not hallucinating packages. This is less if you're using something like Cloud Code or Open Code or GitHub client, because they are nowadays verifying against the source. But the original LLMs that you started using, and if you haven't improved your usage and knowing what you're doing, you can just invent new libraries. I tried a few things and none of them actually worked in today's harnesses, so the ecosystems that you use. But half a year ago, if I would have prompted, I got 3 viruses with 1 prompt. Because it just invented a library that is in C# and it tried to bring it in Node.js. Because I was trying that kind of things. And someone had pushed a malicious code already in those systems. Well, what happens actually when you do this, and this stuff happens, is you get into these situations like, for example, Axios. So you start getting compromised on NPM. So like, you get these malicious versions into the source code. It can be not malicious, and then it gets hijacked. So you have like leftbad, for example. Everybody remembers leftbad from their nightmares. If you don't, happy for you. It was a package that got removed from NPM, and after that it got replaced by malicious code. Everybody who installed it got hacked. Same thing. So Axios, one of the AI libraries, got taken, and after that, the new versions 1.14.1 and 0.30.4 were poisoned. So if you got that into your CI/CD system, what ended up happening is they installed a remote access Trojan, and they got access to your systems. So they could get into any system that this library got deployed to, and because it looked normal, it went through the CI pipelines normally, and got all the way to production in certain systems. SAP had the same thing. NPM packages compromised, and it harvested the developers and CI/CD secrets. How many of you have a GitHub token in your laptop's secrets? Yeah, that's gone at that point. Now it has full admins to your GitHub. How many of you have, at the moment, for example, an open some kind of AI token in the environment variables? If you have, that would have gotten taken. Now they can generate code with your tokens, so free tokens for them. They can push it to GitHub with your name, and they can easily use whatever you have as an access in your environment variable. And that was through one variable, one package. So, fun times. This is the world we're living at the moment. The worst thing is, you have to actually notice it on your laptop. Because if you push it to GitHub or GitLab, what it does is it takes the secrets from your CI/CD and sends those also to the attackers. And now, what do you have as a secret in your CI/CD? How many of you actually have separate environments and profiles and secret fetching for production versus staging versus comparable? And how many of you actually get all of those secrets? So how many of you fetch secrets separately? About 1/10 of the room. How many of you have secrets that are production secrets in your CI/CD? It's my other hand, because my other customer. So all of those would get taken and sent to the attacker. So now your network security defines, are you safe? But if you're using GitHub runners, oh, I have an attack vector to all your source code. And the GitHub can actually access to your deployments. And I have your GitHub token already. So I can push it also to your GitHub. So I can change your GitOps to deploy it to production. Not great. But that's the current day supply chains. The actual work that goes into debugging and finding these is really troublesome and work a lot. If you don't believe that's enough, and you think your language is safe, Go modules, Ruby gems, then credential theft. PyTorch, if you're writing Python and doing analytics, your analytics teams get stolen. So it's in any language that has dependency, we're seeing the same behavior of stealing the tokens and attacking the actual delivery software that we made to make things easier, faster, and better. And just to make it more hitting home, you can also develop it with AI. So when you use WriteLLM, or used for a certain period, that got hacked by TeamPCP. And now they have your whole AI gateway managed by them. And they got few of these. So that means they got free tokens to everything. And it was a persistent backdoor. They could decrypt your encryption. They got everything people were asking. So if you, for example, as one of my customers does, had an HR system connected to AI, because they want to answer people about sick leaves and comparable with AI. They don't collect that info themselves because they are not allowed. But guess what? The hacker can. Nobody is against that. The hacker collects your cancer or whatever you have, and you're asking in your system, how do I actually apply for this? So it's in everywhere. So if you're not scared enough, you might have heard of this. That's Cyberwood from Dune. And we call it now mini Cyberwood because we made it smaller and it's attacking in smaller section. But what this is doing is, this is hunting in the world of GitHub. So if you follow the TeamPCP was behind the previous attack, according to today's sources, they have gotten 4,000 of the GitHub's internal repositories. Not sure if that's true, GitHub is looking into it. But the big thing is, what happened here is they got the worm into one library, they got the GitHub tokens, the NPM tokens, and they made it into a worm. So it gets self-replicating in every single repository that it could, so that they would have access to every place. So the mini Cyberwood over 24 hours got into 160 different packages, got into Mistral, got into TanStack, got into almost every single place that we could think of that is used in AI code. And its whole job was to just keep stealing credentials and get everywhere. And then it sent those credentials back to the staff of the attackers and allowed them to get into the systems and start attacking actually. How we could actually stop mini Cyberwood is we would have to rotate every single package manager in the internet, every single token, and every single GitHub token. For some reason we haven't done that yet. Anyone want to guess why? Yeah, it's a bit of a lot of work. So what your developers see when they're working with AI is their IDE, their instant messaging system, and the version control system. They don't see the web UI, they don't go to Puppy, they don't go to NPM. If they go, they're very well educated. I wouldn't believe in that. So where you need to tackle against these systems is in systems that are built around these three. We know the instant messaging system, they're not going to read any messages that you post, so you have to make a technical systems or make it into cat pictures. They might check your cat pictures. So what we start usually is we build protection around the IDE. So we start creating different protections around there. So we start putting something like Nexus or JFrog curator services, for example. We start creating different kind of prevention systems to prevent them from bullying systems. We're going to get into those. But I have some questions. So raise your hand if you have personal data on your machine. Yeah, that gets taken. You have admin access to your machine. Yeah, now the attacker gets AI access to your machine. You can run commands to production from your work machine. Oh, that's very low actually, but they have no access to that also. You have secrets in your laptop as command line variables. Yeah. That's the statistics from the same paper. So it really confuses packages in JavaScript. So, game over, you might say. So, it's a game over if you pull a language model and the malicious user gets the package, and the package gets to your package repository, and gets to your normal user. So what you have to start doing is you have to start preventing it before it becomes malicious. So we need to start attacking systems here in the package registry. We have to start creating systems in the normal user's laptop, so they wouldn't pull those vulnerable packages. But we are very far behind at the moment in many organizations. So we want to be preventing exploitation in many layers. And it's not just package hallucination as we saw, because now we've found a way to use the package hallucination to upgrade ourselves to higher and higher tiers to get actual production libraries into use. So I made with Gemini a really handy nibble of like info how to actually tackle these and how do you actually run commands in different languages to use dependency cooldowns. You'll be seeing these and these talks are recorded. But the key thing here is what this means is in different languages you can define how long since it was released in different package registry do I pull it from. So you don't get it and let it go and get the package immediately. You give it, for example, 24-hour cooldown. Because at the moment, if it's a popular package, if you're using a popular package, most of the package managers are hunting these things very tightly at the moment. So if you give it like 5 days, they probably removed malicious packages from the system. So you're about 60% more safer. Still, high chance of getting attacked, but you have different ways of communicating and protecting yourself. So you can create like minimum release age. You can create, well in Ruby it doesn't exist, but like .NET users have a possible way of coming in, and there is also update their tools where you can define these. So that's something you can do. That's the easiest way. That doesn't cost you any money. The sad thing is, this requires it to be in every single developer's laptop. And that's difficult. So the other way, I have it from the Nexus firewall, but it's the same principle in JFrog. It's the same principle in any package manager that has curation capability. So new component would get deployed by someone. It arrives to the package manager. This can be any component in any package manager. And it gets evaluated by a vendor. In this case, Sonatype, because I'm using Sonatype slide. In JFrog's case, JFrog security team. And before it gets allowed into your system, they tell it that it's known safe, suspicious, or it's a critically vulnerable or malicious code. And then it gets moved to quarantine area. So that way, you don't accidentally pull code. But the thing is, you have to actually combine this with your package manager, and everybody has to use a remote package manager. How many of you are using only JFrog or Sonatype or Hardcore or comparable packages and never going straight to the source? Well, that's like 5 people. Yay! So the big thing is most organizations see it as too tedious because it requires training staff, it requires network controls, and it requires protecting the end devices so that you are not actually allowed to go to those pages. You can also take scanning approach. So you could have a whitelisting for the vendor, but that doesn't really help. I have lost my one slide. So I'll go back here. The big thing here is you can also do things where you prevent the network access, in the CI/CD at least. So if you're fine on the developer laptop getting taken, so if you're, for example, working on a laptop, but working on the actual systems where the customer data, for example, is, you can easily prevent internet access from the RDP or something else or another laptop. Or you could just do zero trust security, which is a business case. This creates a really good business case, by the way, for zero trust. You can prevent the internet, and that allows you to really tackle against the access towards, external packages from the CI/CD. So what we do with most customers is that we don't prevent the developer environment, because that's difficult. Because then they just go to an external source and they use that external source to pull the packages. Because developers, I'm one of them. So what we do is we prevent CI/CD. We do a protection in CI/CD. You can easily put everything going through a squid proxy, for example. Or if you're in cloud, NAT gateway. Or if you're in somewhere else, you can put like access control limits. And you can guide the traffic to your package manager and force those users to pull from there. So you can also do scanning the new programs that people are allowing, checking an application whitelisting vendors. You would have some kind of whitelisting vendor like dependency track, for example. You could then check with the external database that they would use, and then you would have a manual approval for new applications, and at that point your developer has already gotten the package somewhere. But you could try, some organizations can do this, and then you could try and get time and resources to put into this manual process, and then you can trust certain developments. This is easy in terms of like work if you have one system and one language. The problem is, according to again research, and based on my research, the 62% is bullshit. It's about 98%. Today I heard about 900 different CI/CD tools in the pipeline. So like 62% of developments and companies using 6 or more tools to develop software sounds small at that point. I have so far averaged about 20 different DevOps tools in an average CI/CD pipeline. And that's an average. Some people have more. So when you start putting these packages and package managers, they become part of multitude of points. Because it's not just the source code that you're doing, because the same attacks can happen against these tools. I didn't put the slide in, but if you look at, for example, runtime protection, and you're like, we're protecting our runtime, where Trivi got hacked same way as I was saying before. So what happens? You pull Trivi automatically, and now you have a remote access available to every single machine that is running Trivi. Yeah, not great. Cooldowns. Put the cooldowns in. I also run DevOps toolchain analysis, so I go and check people's DevOps toolchains. Now I'm also doing AI maturity, but that's a different report. And I wanted to highlight in red, as my colleague in history said, every single box here is a security issue. But I wanted to highlight in red the boxes that are critical on security. And the big things are, most organizations that I have talked to have more than one version control system. And those of you in small companies are like, how is that possible? Like, why would they have this? And then you're like, oh, we have an Azure DevOps. Then we have GitHub. Then we have this guy still stuck in SVN. And then we have CVS in use. And then you're like, what's CVS? Well, most of the younglings are in what's SVN, but like, if you know CVS, then you're like, then you've seen some stuff. On the other side, most organizations have no idea how their deployment process works. If you missed the talk, there was a great talk about from Yanis. You can check it on the videos that come out about deployment processes. But most people couldn't describe to you how they deploy software. They would have no idea what happens from the idea to production. They will need like 6 other buddies, and they will sit together on a table and use an hour to mark what goes into a deployment process. And after that, they're like, this is about 80% sure. And then you ask like, okay, what's the 20%? And they're like, well, we have this other team that is doing this. And you're like, okay, how much do they do? Well, that's 50% of our revenue, actually. Fantastic. And then you're a security expert on these two, and you're like, okay, I want to update a log4j package. You need to know where it is, and you need to know how to get it to production. Those two boxes prevent you from doing that, and you have no idea how to get that. Then, documentation is everywhere. So, you can't even go and read it. You can't even get the AI to tell you how do I actually release something, because AI is really bad at finding multitude of sources. By average, I've come to a conclusion that it's about 7 to 8 systems that people put documentation in. And you need all of that to understand how do we actually release something. That's going to get better, by the way, with AI, because everybody needs to put something into Markdown, and then you have everything in the repo, so you can actually know about topics. Then you get into, okay, we are going to update the package, finally. Except the testing and quality is not well defined, so you don't actually know who can say that it actually works. How many of you have a really good data set of test data in the testing environment, and you can say that it works after you change the variable in on remote dependency, and you see it going up? I don't see any hands. That tells you about the test data. Then we have my favorite box, because I keep hearing from people that like security is getting so much money, and I'm like, no, it's not. Like, come on, we all know there's no money in security. The big thing is how you get money as a security is not through talking to management about security. It's going to talking with business and talking with them, how could you enable them? That's a separate talk. But yeah, security is everyone's mind, and everybody says it's high priority until you ask money. It's my favorite also for sales. Like, they tell me that this is critical feature for customers. I ask, how much are they paying for it? And they look at me quietly, and I'm like, yeah, okay. That tells me that it's not actually critical. Then, this surprised me. So EU is releasing an Cyber Security Act, which requires you to have a software bill of material. And when I started doing this, almost nobody in our customers had a software bill of materials. So if you ask them what open source packages do go into your system, they would have no idea what system had what packages. They would just have a big list of these are the dependencies we have in JFrog. And you would ask, where is this package in? And you would hear like empty room. And you are just like, okay, fantastic. I hate saying this out loud because first of all, secret management is the wrong term, but secret management is afterthought. So how many of you would say it's a secret if you have a secret, if you tell it to 200 people? Yeah, that's not a secret. How many of you would say it's a secret if you tell it to 5 people? It's still not a secret, like that's leaking. So how many would you say it's a secret if it's told to nobody? That's pretty secret. The secret managers themselves are capable of doing fantastic work of keeping the secret from even us. But us as humans have not engineered. Like if you ask our Kubernetes expert here, like you can easily integrate any secret manager to Kubernetes. And you would never know what goes into those pods, and you would never know the secrets. How many of us have actually done that? Almost nobody. You're supposed to rotate your secrets, you're supposed to not know the secrets, and then most of us find like the password 1234 as a placeholder password that went to production because nobody remembered to change it. Has happened. Multitude of other funny topics. So basically what I'm saying is all of this leads to the fact that the cyber roots, etc., have become a vulnerability for us because we haven't actually engineered any of our pipelines, any of our processes, or any of our things into a state where we would be able to rotate a secret, for example. So now if GitHub informs us all the tokens are removed, how many of you would have a really, really bad 24 hours? Okay, 3 of us, 4 of us, we're like, okay, yeah, I know it's gonna be bad. The rest of you are gonna find out if that happens. So, usually I want to say something about what to do in this case, and my answer is, think about fixing some of these. I know you're saying, okay, I'm a security expert, I can't really fix these things. So how I usually approach these at the moment is, figure out how it relates to AI. Documentation is everywhere. Yeah, sorry guys, I mean, we can't really give AI a context because we don't have the documentation related to this topic. Should we think about like centralizing this context into this context management system? Yeah, sounds really good. I got the documentation. You could use Green, for example, or there are a multitude of other tools that enable you to search through a multitude of sources and get documentation. Yeah, our source code is everywhere, so we don't really have this capability of giving the AI a capability of doing changes across our code base. So you know that like these automated agents are not really working well. Hey, maybe we should go to one version control. Yes. Oh, we're not really able to monitor and guardrail this AI because we have so many different admins in the version control. So should we like make a actual like pattern of preventing these code changes from being pushed automatically? Sounds good. You can start thinking each of these boxes as an AI enablement, and surprisingly, there's actually money at the moment in AI. So AI foundational problems is the name of the slide. I'm supposed to be out of time here. And I am. So, questions?
Yep, we have to. What are your thoughts of this movement that advocate for abandoning Angular, React, and so on in favor of vanilla JS?
Why would you write JavaScript if you abandon all the libraries? Like, why not write an actual language at that point? Like, yeah, great. I'm all for this, but like, why write JavaScript? But I might be a JavaScript hater, so maybe you have a good idea.
Okay, the second question, doesn't local antivirus on workstation help with information stealers?
So, how often have you gotten an alert from your antivirus on your laptop lately? Because I have an antivirus on my laptop, and I've not heard from it in 6 years.
I heard of positive detections, not from me, but from other.
Okay, so one guy has found gotten some positive detections. So the biggest problem here is the antivirus is planned around malware itself and not against information stealing. Because it's mostly like I'm reading environment variables, looks normal software, and then just pushing them out. So you can make it look really normal as a software. If you actually try to push malware into the machine, then it becomes a problem. And the antivirus will probably get better, but again, the hackers are pretty darn good at this. More questions?
Any other question?
Why Kubernetes was yellow?
What?
You have this square with Kubernetes running. You had this square with Kubernetes deploying legacy application, and it was marked as like anti-pattern, as from understanding.
It's because the fact that like it's an anti-pattern because you're not actually changing how you deploy. So if you go to Kubernetes and you take the same old practice of deployment without actually thinking about making it immutable. So if you have a long-living virtual machine or virtual machine application and you deploy it to Kubernetes, it's not actually solving any of the problems. You're just creating more problems. there was a good answer to this. It might solve your problems if everything else is in Kubernetes already. But if you're just moving an application to Kubernetes because it's Kubernetes and it will solve something, it's not going to actually solve any of that problem. It's just going to create more burden for the staff. If you get everything to Kubernetes, then it's going to help you. But I would rather change deployment patterns and ways of working. So it's all about the rest of it, not about the deploying to Kubernetes. It's about taking the old pattern of running on kubectl against Kubernetes, for example, because that's how we've been deploying, and we have a CI that has full access to your Kubernetes cluster.
Yeah.
So if you have a GitOps practice and you have an immutable image, and you're deploying legacy application, well, you didn't get most of the benefit, but you changed a lot of the ways of working. But that's not what people are doing. I'm hopeful that the Cube Beard will solve it, and go and see Abu Kabar's talk if you are interested about that. It's recorded. It was a good talk.
Yeah, thank you. Any other question?
Okay, time for a movie.
Thank you.
Thank you.